All right, welcome to the exam review. So these are problem 1. You want to write the equation y equals mx plus b for the line that has this slope and goes through this point. So it's just y minus y1 equals m times x minus x1, right? And so y minus 6 equals m times x minus a negative 3, so plus 3. Right? Again, this is number 1. Find the slope-intercept form of the equation. The line that passes through the point has the indicated slope. Question 2 was, we'll get to that, f of, so I'm going to just do these quick. So go ahead and solve for y equals negative 2x, and then this is going to be negative 2 times 3 is minus 6, but I'm adding 6 to both sides, and so that's your solution, right? Okay, the other one here, hopefully you can see that. Again, just plug it into this form, right? So y minus 3 over 2 equals m times x minus 1/2. So that's y plus 3 over 2 whole sides. Okay, so y equals 1/2 x. And then this is minus 1/2, so minus 1 over 4. And then plus, and I'm going to multiply this by 2 over 2 to get that lowest common denominator. And so that's going to be plus 6 over 4. And so I get y equals 1/2 x minus plus 5 over 4. Right. So let me make sure I got the right numbers up there. 1/2, 3/2. Yeah, right. So, yeah, everything should be good, right? Plus 3/2, 2, that's 6 over 4, minus 1 over 4 is 5 over 4, yeah, okay. Okay, I was running on the trail yesterday, and a bug hit me in the eye, and irritated my eye, and about 2 years ago, Nathan stuck his finger, jammed his finger up into my eye and scratched my cornea really good. And so every once in a while, I just get this like phantom irritation. It just never healed. So, anyways, okay, I'm going to, so the g minus f of x, that's just your finding the difference between the two functions. So 6, 5x plus 7, 7x minus 6, 5x plus 7. So when I go f minus g of x, or g minus f of x, I'm taking 5x plus 7 minus 7x minus 6. So 5x plus 7 minus 7x minus 6. So 5x minus 7x minus 7x plus 7 plus 6. So that's minus 2x plus 13. Okay. 7x minus 6, 5x plus 7. Yeah. And then 5x plus 7 minus, yep. Okay, that's g minus f. And f of g. So those are the composition. F of g means f of 5x plus 7, right? And that's going to be 7 times 5x plus 7 minus 6. So that's going to be 35x, and this is plus 49 minus 6, so plus 43, right? There you go, okay? Now, f of g of 1 and f of g of 3. So I found f of g of x. So now I'm just going to plug a 1 in here, and I'll get 78. Right? And the f of g of 3 is 35 times 3 plus 43. That's 105, 148. Right? Okay? So, all right. Write the standard equation of a circle with center 3, 3, radius 9. So remember circles. So I'm just gonna go through here really quick. Center 3, 3, r equals 9. So x minus 3 squared plus y minus 3 squared equals, radius is 9, so it's 9 squared, right? So remember, x minus h plus y minus k equals r squared. That's the equation of a circle. So I've got my center there. Just plug those numbers in. Okay, given the radius and center of the following circle, find the radius. So x minus 5, 1 plus 1 plus 14. Okay, so the next one. Okay, so this is the next problem. So I've got x totally different. Now I gotta find the radius. So the r is the square root of 14, right? Remember, this is r squared, okay? And then my center is gonna be x minus h. So h is 5. And then y minus k. Okay, k is in -1. Okay, so there's my center, there's my radius. Again, the square root of the 14 out there. Okay, so I think on the quiz you had like a 6 equals 6 squared, so it'd be the square root of 6 squared. But okay, number 5. Does the following represent a function? Here I've got, so look at number 5. I've got a circle, okay? So number 5, it's a circle equation. It fails the horizontal line, vertical line test. So it is not a function, right? And therefore it's not invertible. Now, and then for y, I've got 4x cubed plus 5. That is a function, right? For number 6, I'm going to come back to number 6 just because I'm trying to. Number 7. A secant line is, I've got 4x squared plus 5x plus 5. And I want to find the secant line between two, that's the slope of the line between 2 points. So x equals 5 and 1, okay? It's f of 5. So the slope is change in y over change in x, and that would be the change in y, which would be y2 minus, right? So it would be the change in y. So here I have x1, y1, which is 5 comma f of 5, and then the first point would be x1 of 1, f of 1, right? So if this, say this thing goes like this, here's, actually no, here's 1. 1 is f of 1 is 4 plus 5 is 14, and then f of 5 is 25, 100 plus 30, so 130, right? 4x squared plus 5x plus 5, yeah. Okay, so 130. So f of 1 is 1 comma 14, and then f of 5 is like way up here, and I'm looking at the slope between those two lines, which is the change in y over change in x, y being f of the x value, right? So slope is going to be 130 minus 14 over 5 minus 1. 116 over 4, which is 29. Yeah, 29, okay? So I know I'm doing this really quick here. Hopefully you can put it on slow-mo. Okay, find the center coordinates of the circle. Yeah, that one should just be 0, 0, right? So that's x minus 0, y minus 0. Number 9, find the radius of the circle. So that's I've got x squared plus y squared is 4. The radius is the square root of 4, which is, plus or minus 2, I guess, but obviously you can't have a negative radius, so that would be 2. And the radius of the circle defined by the equation. Again, here I've got the 9 squared, so this one, we had a similar-ish problem here for the quiz, and that's I've got a x minus something squared plus y minus something squared, right, equals 9 squared. Remember, this is equals r squared. So what is r? 9 squared equals r squared. Square root of both sides. 9 equals r. Okay, so that one, r is just 9. Okay. Invertibility. Okay, here we go. So I've got a 3x squared plus 4. As is, that's not invertible, right? I just totally screwed up. There we go. Okay, find if it's invertible. The first one is it fails the horizontal line test, right? It's a parabola, and so it's not invertible. And so the inverse doesn't exist. It would be invertible if and only if we restricted our domain, right? But I didn't, so it's not an invertible function, as is. For the following functions, determine if they're invertible. Here I've got another one, 2 over x minus 3. That's invertible. Okay. 2 over x minus 3, so y equals, so here to find the inversion, x equals y, so then I'm going to multiply both sides by y minus 3 over x. So I'm just multiplying by the inverse, trying to get y by itself, okay? Well, you can do it that way. I'll just, instead of dividing, I won't do that yet, okay? So I'm going to get y minus 3x equals 2 times y minus 3. And again, I'm trying to solve for, whoops, y minus 3 over y minus 3, sorry, equals 2. And so here I want to get rid of the x, right? Y by x, okay? And so I'm at y minus 3 equals 2 over x plus 3. So plus 3 goes away. So this is the inversion, right? So just make sure I did that. That's why, I mean, I would have just done this in one fail swoop. But it's fine. So multiply both sides by the y minus 3 denominator there. And then divide both sides by x to move the x over here. And in my domain, x cannot be 0, right? So I'm not dividing by 0. So, and in my other one, remember y can never be 0, so in the range of my original function, now x cannot be 0 in the domain of my inverse function, okay? Okay, so I've got, y equals, this is my inverse domain, x cannot be 0, range, should be all real numbers, right? Except 3, it can never be 3, because here, in my original function, y equals 2 over x minus 3, x cannot be 3, so my domain of my original function becomes the range of this one. Where is my original? X cannot be, not, 0, range 3. Y will never be 3. And that's because x, the domain of the original function, x cannot be 3, becomes my domain, my range, sorry, for my inverse function. Right, so remember the domain and range switch in the inverse function. So here, never be the range, there we go. So the domain of this, the range of the original function is x, y will never be 0, so that's my domain of my inverse. And the domain of the original function, x cannot be 3, right there, and that's my range for my inverse function. Remember I did that. You could plug a 3 in for that and find out why. You'll get a contradiction. Okay, number 13, find the zeros. Okay, 3x to the fourth minus 27x cubed. Plus 60x squared. Okay, so I want to find my zeros, so I'm going to set it equal to 0. I'm going to factor out a 3x squared. So if I divide each of these by 3x squared, I get x squared minus 9x plus 20 plus 20, right? Equals 0. Okay, so either this equals 0 or this equals 0. So 1, x equals 0. So if this is 0, x is 0, don't care about that, right? Or I'm going to factor this to x minus 5, x minus 4. That is, what are two numbers and when multiplied together get a positive 20, when added are a negative 9. That would be two negative numbers. Factors of 20 are 1 and 20, 2 and 10, 2 and 10, no, 1 and 20, no, 4 and 5, 4 and 5 make 9, negative 4 and negative 5, there we go. Okay, so the other solutions are 5 and 4. So those should be your solutions. Again, factoring out a common factor. Everything here is factorable by 3x squared. If I divide by 3x squared, I'm left with x squared. Divide by 3x squared, I get 9x. Divide by 3x squared, I get 20, right? Okay. Okay, so I get my factors. 4, 5, 0. 0 shows up twice, basically, right? So should have picked 4, 5, 0. Right. And by the way, you only need to hit 0 once. Because there's only one 0. But oh, so the last one, number 14, find the inverse of x plus 1 over x minus 1. So by the way, the domain and the range is all real numbers. The domain is x cannot be 1. So so what's my inverse? Think of the range. It should be all real numbers except this is 1. 0. I think 0. Let me just check. No, I think that's okay. So let's find out. I have to graph it, but I'm looking what my range is. So we'll see. So I'm going to switch the x and the y. So x equals y plus 1 over y minus 1. I'm just going to multiply by y minus 1. Right? Okay. And yeah, just going to do that. So then I'm going to get y, xy. I'm going to go ahead and FOIL that. In fact, distribute. Yx minus x equals, that cancels, equals y plus 1. So now I'm going to subtract y from both sides. I'm going to subtract y, and I'm going to add x, by the way. Okay, so I'm going to move this x over here by adding it to both sides, and I move the y over here, so I get my y's on the same side by subtracting it. So minus y plus x, right? Okay, so I'm going to get xy right here, and then minus y equals, let's cancel, equals 1 plus x. Okay. And so I'm going to factor the y, x minus 1 equals x plus 1, just x plus 1, 1 plus 1, same thing. Divide by x minus 1, divide by x plus 1, right? And I get y equals x plus 1 over x minus 1, and I actually get the same thing here, right? So domain x cannot be 1. So I guess 1. 1 is the one thing that it cannot be. right? Yeah, so if you just set this equal to 1, can y be 1? 1 equals x plus 1 over x minus 1, so I'm going to multiply both sides by x minus 1. X minus 1, I get x minus 1 equals x plus 1, right? And so then I subtract x from both sides, I get negative 1 equals 1, contradiction, right? So it cannot be. And if you graph it out, what you'll get if you graph this out is x equals 1, y equals 1, going to get a perfectly symmetrical about that axis, right? So that means the inverse and the function itself are identical. Okay, so I went over those really quick. You can slow that down, reverse it, ask me on Monday, okay, if you have any questions, but hopefully that did help some. I can come back and review the one that I skipped, but I just didn't want to talk about it on the board since it's not really a board question. So what I'll do is I'll move over here and go back to it. Which one was it? It was this one. Yeah, so I had the graph. Let's look at the graph, see what it is. Okay, is that a function? Yeah, it's a function, right? It's not invertible because it fails the horizontal line test, but it is a function. Okay, what's the domain? Domain and range, all real numbers, right? Range, all real numbers. What are the zeros? When you look at it, where does it cross the x-axis? -2, 0, +2. Okay, yeah, so there you go. That answers that. Okay, I'm going to pause that, and if you guys have any questions, let me know. All right, be back. I'll see you guys on Monday.